Hello guys, in this video I would like to explain about the application of standardized table in reverse. In the first lecture, we have done the application of standardized normal table. You know, in that case, we have we were needed to find the probability for a specific value or values of a random variable. That is, we normally say x, that is suppose normally distributed, and z, which is also normally distributed but standard normally distributed. That's mean with the mean 0 and variance 1. So so that was the first application of standard normal table. In this video, we would like to find the values of the random variable for a given probability. So this is now in reverse to the first application. The first application was to find the probability for the values of a random variable, and in this lecture we will find values of the random variable for a given probability. Let's suppose this is the probability that 0.7422. So for this value, you can see the random variable, the values of the variable that is called z in this case, the value is 0.65. So if this probability is given and you are asked to find the value of the z, then that is 0.65. So this is the value of the variable for the given probability. So let's explain this in detail with the example. We have this example. There are two questions in this example. Given a normal distribution with mu is equal to 40 and sigma is equal to 6, find the value of x that has 45% of the area to the left and 14% of the area to the right. So there are two cases. This one is in 45% of the area to the left, and the second one is 14% area to the right. So we need to find the value of z first, and then we need to convert that to the value of x. So let's start from the first, this example, 45% of the area. You can draw this diagram. That's very simple. We will need to open OneNote for this case. OneNote. Okay, OneNote. If you want to do this manually, we can do this. We need to open this. Yes, we have done the previous example with this. So just close this. This is ended. So you can draw this just like which is drawn in the book. So this mean is 0, standard normal, and 45% of the areas look like here somewhere. Oh, it's not too close. It's something like here. And this value, z value, is unknown. Suppose this is z. Now we just say this value. So what is the value actually? We have, this is given the variable, and z naught, this is the specific value of the random variable, which is equal to 0.45. So this is the statement actually. About this problem, this is the statement. This area is given by the statement which I have written here. Let's read this first, and then we will go back and we will see how we can do this. Like manually. An area of the 45 to the left of the desired x value is shaded in figure 6.13a. So this is shaded. Okay, we have done also. We require a z value that leaves an area 45 to the left. Okay, from table A3 we find probability of z less than. So this is the value of z naught. But how we can find this from table, because this is already solved example. So this will not help us in exam actually. Okay, so let's go to the table and find this value. Remember, the probability is 0.45. Okay, let's go to the table and see. You need to find the probability 0.45. Zero point 0.45. Okay, this one 5. Okay, 4.2, 4.7, 4.4, 4.5, 4.5, 2.2. Okay, these two values are close. This is 0.4522 and this is 0.4483, and rather this value is closer. So this value can be, this is, this value, just look at this, 0, 0, 0, 1, 0, 0, 2, and 0, 0, 3. So this can be minus 0.13. Now let's see how they have solved this. Yeah, this value is minus 0.13. So how you can find this value? Just go back to the table. Yesterday we have found the probability for a given value of the random variable. And today in today's lecture we have the probability is given to us and we need to find the value of the random variable. So you can see that this value is closer to 0.45, as compared to the other values. So this is the closest value to 0.45. If you round up, then this is 0.45, of course. So what is the value of random variable? That is, what is the value of z? That is minus 0.13. Minus 0.13. Okay. So just go to the table and you found that probability of z less than minus 0.13 as 0.45. So this is the value of z naught which you are required, minus 0.13, and this is that value which you can write here. Now if you look at the question, in the question they ask find the value for x not for z. And just go back, find the value of x, but remember that mu is given, sigma is given. So how you can go back? Just look at this. You know that z naught, suppose we write this, z naught is equal to x minus mu divided by sigma. So generally we can solve this for x. X is equal to mu. You can multiply this here, sigma z naught, and then just, okay, I will do this in detail because I don't know. If you don't understand, this can be a problem. Okay. So this can be solved that like sigma z naught is equal to x minus mu, and now you can solve this for x. Just shift this mu to here and this will become plus with this. So that's mean mu plus sigma z naught is equal to x. That's mean x is equal to mu plus sigma z naught. So in that case, in our case, we have mu, that is, you can just go and look, that is I think 40, and sigma is equal to 6, mu is equal to 40, sigma is equal to 6, and you already found the value of z naught. So 40 plus sigma, that is 6, and 2 minus 0.13. So solving this, you can find the value of x for this particular problem. And you can see this is solved like this. Yes. Okay. That is 39.22. That is 39.22. So the first part has been solved. Now second part of this question, that is second part of the question is that probability area 14% of the area to the right. You can plot this as well, in exam. So this is second part. This is part B. You can plot this. Not good, but you can write this 14% is something here. This area, and this is Z naught. And remember that the mean is always 0 per standard normal distribution. Sigma is equal to 1. Okay, so this is now 14% of the area. Remember that the total area under the curve, the normal curve, is 1. So in percentage, we can say 100%. So 14% is here. So how much is here, by the way? This is 86%. This is 86%. And probability, in a probabilistic term, we can say this is 0.86 probability, this area. 86% or 86. So what you need to see that, because the table is constructed in a cumulative way, so you need to see this way. You can see that you can see the value of z when you are looking 0.86, because this value, this probability is here until here 0.86. This the probability of this value less than this value, that is 0.86, and the remaining, this is 14%, and the total is of course 100%, or you can say in probabilistic way, that is 1. So you need to see this probability, this value, and just check the value of z against this value in the table, and you will find this value. So we are not caring now with this, we are caring with this because we need this to see this value in the table, and that will give you the value of z naught in this case. Let's see how. Okay, let's see 0.86. The probability is 0.86. Just look at the table. This is now close, 0.85, 0.8599. So this value is much closer. Okay, so let's see this value as you can go, you can see 1.08, because 0 is here and 0 is here, the first value after decimal, and 8. This is 1.08. And look how they solve this. This value is 1.08. Just look at this. How you can write the statement for this? You can write the statement for this z less than z naught is equal to 0.86, and z naught you saw from the table, this is probability of z less than 1.08, that is equal to 0.86. So this is the value of z naught. You have found this value. Now how you can convert this, how you can find the value of x in this case? Again, remember that z naught is equal to x minus mu divided by sigma, and we have done in the previous part of this question, x is equal to mu plus sigma z naught. You already have the value of mu, that is 40, plus the value of sigma, that is 6, and z naught is 1.08. Just solve this for x, and you will find the value of x, and that can be higher than 46. This can be higher than 46. Yeah, that is 46.48. 46, find 48. 48. Remember that we were asked to find the value of x. If you are not asked, then you need to find the value of z only, and you will stop here. Okay, this is all about how we can find the normal curve or then the standardized normal table in reverse. Usually we find probabilities for the given values of the random variable. I mean, that can be x, we convert then that to z, and then we find the probability from the table. But if the probabilities are given or the probability is given and you need to find the value or values of the random variable, that we call the reverse application of the standardized normal table. So we have done this with the examples, and I will do another example in which both values we will need to find both limit. There will be a variable between two limits, z1 naught, z2 naught, and we will need to find these two values in the next video. And I would like to have a video that will explain the standardized normal table in detail, and another video in which I will explain that why we need standardized table. So I think this is enough for today, and see you in the next video. Ciao.